accidentally hit the button, shut the camera off. There's another way that we never did in Algebra 2. That was for when interest was compounded, like monthly or yearly or daily or whatever, any amount of time but we never did continuously compounded interest. So we gotta do that now. There's a nice little proof on where this formula comes from on page 355 if you want to check that out. Basically, to begin with, it says dy dt equals ky, where k is just some constant. And so the change in y is equal to some constant times whatever y is. And that makes sense, because like back when we used to do this, if we made a table for this situation, we would have started off with x, y. After 0 years, we had $100. After 1 year, 20% increase, so we'd times by 1.2, and we'd have 120. And then you times by 1.2 again, you'd have 144, and then you'd multiply by 1.2 again, and I don't know, you'd have something else. I don't know what that is. The point is, the change in y is equal to just 1.2 times whatever y is. That's all this says. And so if you take this equation here and you solve for y, which this is a separable equation like we just did in that first example, you come up with the final equation that y equals the initial value, that's what y sub 0 is, just means the initial value, of e is good old e, to the kt, where, like I said, y sub 0 is the initial value, k is a constant, and t is still time. So this is really close to our old ab to the x. The only difference is that e is in there, and there's that k is, that's a little different. So just doing an example here of continuously compounded interest. We'll do the example both ways, our old way and the new way. It's just example 2 here. It says you have $800. You deposit into an account that pays 6.3% annual interest. My U's and N's look the same, I just noticed. Interest. How much will you have 8 years later? Years, there we go, later, if, so the first way is if the interest is compounded continuously, so if interest is compounded continuously, there we go. And B, if it's compounded, well, we can do annually, maybe quarter, we'll just do annually. I don't know how to spell words, and that's wrong, who cares, whatever. Anyway, it's one of my worst performances ever on this video. So here we go, if it's compounded continuously, we'll do that one first. For that, we're going to use our new equation here. Y equals the initial value times e to the kt. All we got to do is plug stuff in and go for it here. Y, how much will you have? That's y, so we don't know that. Our initial value is 800. E to the k. That constant, that's just your interest rate. How much you're going to multiply by every time. So in this case, it's 0.063. And since it's annual interest and we're doing 8 years, our time is 8. If this said annual interest and then this said 8 months, we would have to do, we couldn't put an 8 here, we would have to put 8/12, because this is annually. Or, you know, vice versa, if this said monthly interest rate, which it'll never say that. That's stupid, that's not realistic, so forget I said that. So there we go, plug that into your calculator. 800e to that, and let's see what we get here. Where's E? It's raining. Maybe you guys will get a 2-hour delay in the morning. I won't, because I gotta go stupid Wenatchee. What? This is not right. $6,000? I don't think so. I know why. The calculator, if you punch it in the way I did, the calculator will take 800 times E. It'll do E to the 0.063 power, and then multiply by 800, and then multiply by 8. So what you gotta do is do 800 E to the and then put another set of parentheses, or you don't need, I don't know, you don't really need those, 0.063 times 8 in parentheses, because you want it to multiply the 8 and the 0.063 first, and do that to the E power. There it is. So you'd have 1324/26. You only made $500 in 8 years. So the way that's different, compounded annually, that'd be like our old way. Just our y equals ab to the x. If you look in the book, they do not do it like this. So, yeah. So yeah, there's just something to point out. Compounded annually, 8 years later. The thing was with annual interest, since we have 6.3% annual interest, oh, we're doing compounded annually, so that's easy. It's just there. Yeah, never mind. Great video here. Yep. Initial value is 800. B would be our multiplier, so we would just do. Remember, we would do 1.063 because there was an increase, and to the 8th power, and that's all you would have to do for that. And you would get 800 times 1.063 to the 8th, $1,304.24. So not as much. This whole compounded continuously thing, I just think that's weird. That's hard to wrap my head around. I'm not a financial expert or an accountant by any means. I don't really understand it. Compounded annually makes sense. Every year they compound the interest and add it to it. Compounded continuously, what's that mean? Like, I don't understand that, but that's how you do it anyway. So that's just one use of exponentials. You might be wondering, well, where was the calculus in that? Well, the calculus in that was up here. We kind of skipped it. It was in the proof of getting this equation. That's where the calculus was at. So we're going to kind of skip it again on this next part. Another exponential situation, half-life. Day probably just perked up in her chair. She always liked this. So if we're going to find the half-life of something, it's the same kind of situation here. If you take the initial value of something, it's going to behave exponentially like this. So you could have the initial value e to the kt, and for half-life, that would be, we could figure out how long will it take. So if we solve for t, and how long will it take to give me half of the initial value. That's how you would set that up. So I have my initial value times e to the constant times time, and that will equal half of my initial value at some point. If I solve for t in this equation, which they do on page 356, 357, there's the proof. As it turns out, half-life, all it equals is always is the ln of 2 divided by k. Kind of weird. So you'll see in your homework, big hint, all you have to use is this equation. Like they could say, you might have to find the half-life given some equation. Well, just use this. Find the half-life given some equation, just plug in k for that. And if you have to solve for k and they tell you the half-life, just plug in half-life there and solve for k. It's really easy. Do not overthink it. I'm not even going to do an example. I'm confident you can figure it out. It's literally just that simple equation. We'll do a little more of this tomorrow. It'll get better. This wasn't too fun, but here's what you need to try to do. 7.4, I like all of the quick reviews. I think. Let me see if I still like them. Yeah, that's good stuff. 1 through 10. And then also those numbers 3 through 6, 15 through 18. And I have no idea why I'm writing it like this. 21 and 22. That's it. Hopefully I didn't blabble on too long and you got some time to work on this before you get out of here. See you tomorrow.